Hello everyone, this is the video for lesson 7.2 and we're going to talk about box and whisker plots. So your goals for this lesson is for you to be given a set of data to be able to create a box and whisker plot either by hand or using technology, and we're going to use Desmos a lot in this lesson. And then you're going to be able to interpret the data in a box and whisker plot and answer questions about the data. So if you look at your notes, you already have an example of a box and whisker plot here. What a box and whisker plot does is it splits your data up into quarters. So you've got 25% of the data here in the left whisker, and then you have 25% of the data here on the left side of your box, and then you have 25% here, and you've got 25% here. And as you can see, this data is spread out differently according to whichever quarter that you're looking at. So you can kind of tell right here in this third quarter, it's not very spread out compared to the second quarter right here, which is very much spread out. So you can very easily see the variability of this data. Now, the only measure of center that you can see is the median. And remember, the median splits the data into halves. So half of the data is going to be to the left of the median, and then the other half of the data is going to be to the right of the median. This box right here also contains the middle 50% of the data. And we actually use that to describe skewed data, which we're going to talk about in lesson 7.3. All right, so let's make a box and whisker plots on Desmos. So bring up Desmos on your computer and type it in like you did before in lesson 7.1. All you have to do is use a capital letter, equal sign, and then open little bracket right there. Just double check and make sure you have 10 numbers in your data. Once you get that, I'm going to go ahead and type in stats. And what that does is it gives you something called your 5-number summary. You'll see why. You get 5 numbers. Now, these are the 5 numbers that you need to create a box and whisker plot. So right now we're going to do this by hand, but I'm going to show you how to do the box and whisker using Desmos. So take a second. We're going to jot this down, and I'm going to write this on my notes as well. Pause the video, write it on your notes. Okay, I've written down all of my 5-number summary numbers, and let's get started on graphing this box and whisker. Now, when you graph the box and whisker, make sure that you put the dots above the line. This is not a number line drawing, so you have to go above it. So this minimum over here, I'm going to put the dot here. Do not put it on the 18. That's not how that works. Okay, so that's the beginning of my data set. Now I'm going to go to Q1, which is 22. So Q1, what that is that point where you have 25% of your data right here. Now, you don't have to put the 25 in there, but when you go all the way up to Q1, that's where your box is going to start. So make sure you leave room to draw your box. Now we're going to go to your median. So to your median, that splits your data into half. So you got 25 here, and then you got another 25% here. But I'm going to put median way up here at the top because I'm going to draw a box. Then I'm going to go to Q3. Q3 is going to be where you have your third quarter. So you've got another 25% of your data right here. Okay, so now I'm going to go ahead and I'm going to draw the box. So the box is like this. You got a rectangular section in the middle of your box and whisker plot. So you got 25% here. You got 25% here, 25 here, and then let's go ahead and draw all the way to the max, which is at our 30. And that leaves us with our last 25. So if you take your highlighter, you can just highlight all this section right here. That is considered the middle 50% of the data. Okay, we use that a lot if we are describing things that are skewed. Once again, that is in lesson 7.3. So now that we've drawn that by hand, let me go over here and show you what a box plot looks like. So just type in box plot. Now, if you don't remember to type in the word box plot, what you can do is you can select your keyboard here, go to functions, and then scroll to visualizations. Okay, so we're going to go to box plot for a box and whisker plot. So click on that. Yep. So when you do that, make sure that you are in an empty box there. So I'm just going to type box plot A. Now you notice I don't see anything. I don't see anything at all. So your data actually starts at 18. So that makes sense because you can only see up to like 10. So this is really neat. You don't have to mess with the zoom. All you have to do is click on this little zoom fit button. There it is. Okay. Now the big disadvantage though is that if you click on it, you can't really like tell where any of these points are. So if you have to like, you know, name your max and your min, or your medium and your Q1 and your Q2, you need to run your stats. So I can tell right now that this is 18, this is 22, this is 25, 28, and 30. So sometimes you can tell really easily and sometimes you can't. All right, so now that you know how to find the 5-number summary on Desmos and to graph your box and whisker plots by hand and on Desmos, we're going to look at a plot that's already given to you and we're going to interpret the data. So first question, it says find and interpret the range. So you've got to remember that the range is the maximum minus the minimum. So on your box and whisker plot, this is your max and this is your min. So you have to find the numbers. Your maximum is 300 and your minimum is 160. So if you subtract those two numbers, you wind up with 140. Now, this actually represents song length in seconds. So that means that your song length varies no more than 140 seconds. Because remember, range talks about how your data differs or varies because it is a measure of variation. All right, second part, it says describe the distribution of the data. So if you're looking at a box and whisker plot, what you would do is you would say the first 25%, we will talk about the middle 50%, and then the final greater 25%. So the first 25% has songs that last between 160 and 220 seconds. So 160, 220. That is the first 25% of data. So your middle 50% is right here. It's everything in that box. So it goes from 220 to 280. So I'm going to say 220 to 280. I could put more words in there, but we don't have a lot of time. So 25, the top 25% of data is going to go from 280 to 300. So 280 to 300. Awesome. All right, we've got a new formula here. So take your highlighter and highlight that formula. It is, I don't think it's on your Algebra 2. It is on the statistics formula sheet, but you're in Algebra 2, so I don't think this is given to you. So if it asks you about an interquartile range, what you need to do is you need to find Q3 and Q1. Now this is Q1, this is Q3. So all you have to do is plug in these values. So Q3 is 280, and we're going to take away 220. And what that does is it gives you the range of the middle 50%. So the middle 50%, okay, so the middle half varies no more than 60 seconds. So this one is more of a visual question. It says, are the data spread out below, more spread out below Q1? Okay, so this is below Q1 and this is above Q3. So which one is more spread out? The first 25% or the last 25%? I mean, it's literally, which whisker is longer? So it's going to be the first one. So it is more spread out below Q1. So next we're going to talk about the shape of your box and whisker plots. And we're also going to revisit shapes again in lesson 7.3. So if you look at your box and whisker, you can kind of see that this left whisker is really big compared to the right whisker. What happens is that you've got this like outlier over here, or just one or two like really small values. So that means that most of the data is going to be hanging out over here, and you are going to name it for the tail. So this is more spread out here. And if it's more spread out to the left, you're going to call that skewed left. Let's scoot over here to the right. You see how you've got more spread over here? That means that you've got a couple of really big numbers that's pulling your data to the right, and most of your data is hanging out over here on the left. You're going to call that a skewed right distribution. The one in the middle is pretty obvious because you can kind of see that the left side and the right side match up. So these are going to be considered symmetric. And the median should be in the middle of that plot right there. I did not mean to mark that out. So now we know how these are distributed. Let's take a look at this example. So we got a double box and whisker plot. We are comparing your class scores to a friend's class scores. It says identify the shape of each distribution. So if you look at the blue one up here at the top, this one looks like it's got kind of a really long left tail. So that's going to make this one a left skewed box and whisker. And if you look at this one, this is your friend's class. You notice how these whiskers look about the same size. So they're going to be symmetric data. Which class test scores are the most spread out or more spread out? So a lot of times when you're looking at variation, you're comparing between two graphs. So which one is wider? This one takes up way more space than your class. So that means that your friend's class, is more spread out. That means there is more variation in scores. So you're going to have some really high highs versus low lows. But your class, on the other hand, the one above it, that one's a little bit more consistent. It looks like most of the data is kind of hanging out right here. So this one's like spread out all the way between a 60 and 100. So it's just a little bit more consistent. The scores are in your class than your friend's class. All right, so we're going to finish up the lesson by looking at outliers. In lesson 7.1, you just kind of were able to look at the data and figure out if it was really small or really large compared to the rest of the data, but sometimes it's very hard to tell. So if you kind of look at these batting averages right here, they all kind of look like they belong. So you've got one of two options. Either you can use these formulas. This one is Q1 minus 1.5 your IQR. And this one is Q3 plus 1.5 the IQR. You can use those if you don't have the ability to graph using Desmos. Now, we're going to graph using Desmos. When you do graph it using Desmos, it will give you the outliers in like hollow circle form. You'll see it in a minute. So I'm not going to show you how to use the formulas, but they're here if you are curious about it. So what this formula does is it takes your first quarter boundary, which is Q1, and depending on how big the middle 50% is, it's going to subtract a certain amount. So that's kind of going to be like your boundary. So any numbers less than the number you get from this formula, that is going to be considered an outlier. And it shows you right here. So this is like your invisible boundary of outliers, and anything to the left of that is too small for the data. Likewise over here, go ahead and you make your calculations. Anything to the right of this is going to be too big for the data. But here's what I want you to do. I want you to pause the video. I want you to type all of these batting averages into Desmos, and we are going to create a box and whisker using Desmos. Okay, so I entered all of the information into Desmos. I have 12 different numbers, and I have typed in box plot of set A. Well, you can't really see because all of these numbers are between 0 and 1. So what I'm going to do is I'm going to adjust the zoom by clicking on this little magnifying glass. So click, and that's much, much better. So it's really obvious that I'm going to have a couple of outliers. And what's really neat is that before you weren't able to click on parts of your box and whisker, but you can actually click on the outliers. So I have two outliers. I have 0.174 and 0.406. Okay, now before I actually finish the question with the outliers, it does want me to make a little sketch. So I'm going to draw something that looks pretty close to it. So the inner 50% looks pretty close. Let's see here. Oops. Where did it go? There it is. It looks a little bit longer over here. It's fairly symmetrical. Oops, not doing a good job. There we go. So it is definitely symmetrical. If it is skewed, it's going to be pretty obvious that one of those whiskers is going to be longer than the other. And then we're going to write down our outliers. So we have 0.174 and 0.406. So you don't have to use the formula. You can just use Desmos and figure out where those hollow points are. And that's it. And just let me know if y'all have any questions.